We had a request to do another mechanism from Winter 22, Test 4, Part 4, Question 4. That's a lot of fours. And this is all about dehydration of alcohols. Here's the normal alcohol dehydration, and over here is the vicinal diol dehydration, also known as the pinnacle rearrangement. You don't get any points for writing that down, but both mechanisms, you got to protonate an O to make it a better leaving group. So let's just do that 3 times. Protonate O. Some of the products are going to come from that O, I promise. Some of the products are going to come from this O. Please don't go to the same sulfuric acid. I've seen it in this class. A student used the same molecule of sulfuric acid to do 2 different things. And they will verify they lost a point when they did that. Yeah. Oh, yeah, there was no winner between 12, 22. Thank you. Yeah, we want to have the right test so we can get a blank copy for ourselves. So we're generating 3 different oxoniums here. Easy to draw 6 and 5. Leaving group. This one's going to make this one. Leaving group on a tertiary carbon is going to leave faster than leaving group on a secondary carbon, right? Oh, don't forget the other OH. Didn't disappear. Why did we protonate these 3 alcohols? Okay, that's how we did it. Sulfuric acid and we'll protonate an alcohol, but we wanted to make it a leaving group. That's a hint for the next step. Make it leave. That's it. Leave. 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 Cation, cation, cation. Cation. Nope. Cation. And I'm going to do you a big solid. How many products you see for this last reaction? 4. A, B, C, D. I am pretty sure 2 of them came from the first cation and 2 of them from the second. I'm telling you. You need 2 copies of this one and 2 copies of this one. I'm just telling you right now. And you're going to do different rearrangements for each one. One of the rearrangements is going to be from this H all the way, and the other is going to be from the C. Ooh, do we have a product with a square in it? We do, don't we? I see it. It's product C. Otherwise, I'm saying, oh, I don't like that very much, but I'm seeing the C, so I have to come up with a C. And this one's not about rearranging, it's about finishing. How do you get the double bond? The conjugate base that you made way back in the first step. You're going to need a lot of these conjugate bases. You can grab an H from either here or here, which is the only relevant one for this question. The first one. It's possible to remove this one, but I didn't make you do it. There's no product that has a double bond there. So you don't need that H. It's beta, and it's a candidate, but you're not using it in this question. The other one gets you there. You just use the lone pair to grab the H. Sigma becomes pi, end of story. Not bad. Let's do our 2 rearrangements. What do I get from this one? And what do I get from this one? Copy everything except for the bond you moved. When it's H shifts, it's pretty easy to see. With carbon shifts, you really got to follow those instructions. I didn't touch the 6. I didn't touch this bond or this bond. Okay? I didn't touch this bond or this bond. But I did move this bond from here to here. And where is your cation? Always. Look at the example above. Where was the cation? On the carbon with the O. Carbon with the O. On the carbon with the O. You lost a bond there and you didn't get it back. And tell me why it's a good idea to now make sure you draw this bond so that I can go to C using my base, OSO3H negative. This is an E1 mechanism. You got a cation, you grab a beta H. You having trouble with it? You're not used to calling it alpha beta when there's alcohol present. Why not? The elimination mechanism involves removing was remulves. I made a new word, that's weird. Involves removing a beta H. Beta is the position one away from the leaving group position. Leaving group position sometimes doesn't have the leaving group anymore. It has what in its place? A cation. Okay? So I call alpha now the cation carbon. And that gets the product C. C should be over here. What about this one? What's it going to make? It's the same rings and ketone on the small ring. Same rings, ketone on the small ring. That's A, right? So how do I get that to be A? Yeah, I got to move some stuff around. You go there. How do I get this to be A? Conjugate base, thank you. Minus charge. Grab H, sigma becomes pi. It's elimination, guys. And we got 2 copies of the other cation. I did this rearrangement, I did this rearrangement. I never made, oh, this is not equal anymore, is it? This made that, which made A. This is the same as this, which rearranged to this and made C. I need 2 copies of this one, which I didn't do. I started talking before I started finishing what I said I was going to do. Don't be hard on yourself, everybody. What are your 2 possible rearrangements from there? Remember, you have to make D and B, right? One of them comes from making this rearrangement. And the other comes from making this rearrangement. Another ring size 4, not happy. Pretty sure that's going to be the D. But once again, if you can't see it, it's not the end of the world. Copy everything except for the bond you broke. So the outside skeleton did not change. But you did move this one over to there. And now you have an O with an H. And where's the cation? Always after this rearrangement. And it's why the rearrangement happened. It's on the carbon with the oxygen. Why is that good? It can resonate with the oxygen. It's actually part of their mechanism. That doesn't look like it, but it's, isn't it product C? B, sorry, B. C, we did C. Yeah, thank you. B. Yeah, it's got a big ring with a square attached to the right, and the carbonyl is going to be one away from the bridgehead. Yeah, I like it. And that's going to go to B. As long as you use the right base. There's a lot of repetition in these big mechanisms. I'm hoping you see that as an opportunity. This one, copy everything except for the bond you broke. The 5 stayed intact. The 6 is now from here to here. The O is still here. And the plus is there. That looks like, it doesn't look like D, but it's got the right arrangement of atoms for being D. It's a bicyclo 4, 2, 1. It is 1, 2, 3, 4, 1, 2, 1. And we'll actually do a nice arrow to get you to D. Grab H, sigma becomes pi, end of story. Now, I know we're not done, we got a couple loose ends here. Choice of products, you're not picking those with ring size 4 in them. Look at where A came from, a secondary cation that can resonate with O. Look at where D came from, a secondary cation that can resonate with O. I'm not seeing any advantage of one over the other, are you? So there's actually 2 major products. I'm going to say both come from a secondary C plus that can resonate with O. And I'm going to point to both of these guys. And C and it's about B and D, right? Those cations go to B and D respectively. Both are secondary C plus that resonate with O. That's a terrible looking A. It looks like a D. Resin dates. I think that's a good enough explanation because they both go to B and C. Not B and C. B and D.
But you have 4 parameters in
Oh, I don't like B, 4 carbons. I didn't grab the right, A and D, right?
there. No, I'm saying you have 4 parameters.
No, it's got a 5 ring out here and a 7 ring there. D's good. No 4. A, no 4. So which one went to A? I don't like C or B. Yeah. This guy went to A. Yeah, that's the secondary cation. That's a primary. I don't know why I'm pointing to this. That's unrearranged. It can't resonate with O at all. I'm losing my mind. I'm sorry. It's okay. The comment was good. This wasn't pointing to the right cation. There. Both are secondary C plus that resonates with oxygen and don't suffer. What's that bad thing for those ring size 4? Yeah, I need those magic words. Angle and torsional. Don't suffer from, I can't say that. Suffer less from. Wow. Picky, huh? Suffer less from angle and torsional strain. And I think we still have reagents to make the vicinal diol, which was on our first activity today. See that reagent only box? What's O, little s, big O for, and chicken foot, O peroxide, H. So there you go, finally. I think that's a good end for the day. And